And the act of moving onward means we pass these signposts. One of them was first leaving Earth. The next one is hanging out on the moon. What's next? The planets. Onward to the edge. We're moving onward to the edge. Here we are together. This fragile little world. This fragile little world. Onward to the edge. We're moving onward to the edge. Here we are together. This fragile little world.
Hello and welcome to another episode of Voices from L5. Today I have Brent Sherwood, a space architect and program manager of the Solar Systems Mission Formulation at JPL. Hey Brent.
How you doing, Liam?
I'm doing great, thanks. Brent wrote an incredibly interesting article called What Will We Do on the Moon? And seeing as we often talk about Mars and freestanding space settlements, and recently we even talked about Venus settlements, I thought it was time to give the moon a good shot. So Brent, why don't you summarize that paper for everyone and let people know a little bit about who you are and what you do?
Okay, so I guess the first thing to say is that the moon has been, it gets a bad rep these days. You hear people who've been there saying that we've been there and done that. It's easy for them to say who've been there, but the rest of us haven't. And there's an awful lot that remains to be done there. And it will turn out, I believe, that the moon has a unique role to play in the human breakout into space. Kraft Ericke years ago wrote that if God had intended man to explore space, he would have given him a moon. And there's a lot of legitimacy in that argument because the moon is a planet-sized object with the same surface area as Africa, and it's located only 3 days away. And it's a place that everybody is familiar with from looking up in the sky and seeing the face of the moon that faces us. So it's a very present and very meaningful but very hostile place in the solar system. And there's no question in my mind that it will be a beachhead for humans reaching out beyond Earth. So what we were chatting about a little bit ago was a framework that I like to use when I give talks to audiences about the potential uses of human spaceflight in our future. And so I've worked on human spaceflight futures for several decades. And in my mind, it comes down to 4 different types of uses of human spaceflight, and they're very different. One is to explore. That's the familiar one. That's the one that's causing NASA to say Mars is the horizon destination, and that's where we're going. And the whole idea is to be able to get humans as far away from Earth as possible and get them back, and to do that kind of exploration, put humans in an alien environment and explore.
I love the way you put that. Put them as far away from Earth as possible and then bring them back. That's really great.
Well, that's exactly what NASA believes its charter and mission is. And in fact, that's the reason why, if you're on the explore path, the moon isn't good enough because it's not far enough away. But there's 3 others. One is what I call the experience path, which is incredibly different from the explore path. Its goal would be to open space to average people. And if you imagine spending what it'll cost for getting us to Mars someday, we just take a little detour to the NASA budget. NASA gets $18 billion a year. More or less 2/3 of that, one way or another, is directed at human spaceflight development and operations. So you can, in round numbers, call that 10 to the 10th dollars per year. If you spend that amount of money over a decade or 2 or 3 or 4, that's 10 to the 11th dollars. So if you spent that money over 30 or 40 years, you could get a half a dozen civil servants on the surface of Mars, a couple of whom would be U.S. citizens because it would be an international undertaking. If you spent that same investment and that same time on the experience path, instead of a half a dozen government employees on Mars someday, you could have hundreds of thousands of ordinary people flying in Earth orbit on 2-week vacations every year. It's just a different future. but it's a future in which human spaceflight means something very different.
Yeah, wow.
So that's the second path. The third path would be to exploit space using human activity. And that really comes down to, there's lots of options people have talked about, but ultimately it comes down to one of three types of resources. The first is rare earth elements, which are rare on Earth, but are industrially extremely useful for high strength magnets and for they're in the screen of every smartphone on the planet. These are very important elements that we typically get from mining activities in China today, but which occur in higher abundance on the surface of the moon. So that's one thing, rare minerals that could be mined on the moon.
Talking about things like helium-3 and that sort of thing there, right?
That's the next one.
Oh,
That's
okay.
the second category.
Jumping the gun.
It's unique volatiles, of which the primary one would be helium-3, which is also in the lunar regolith in relatively, retrievable abundance, we should call it. Helium-3 is potentially relevant for use in fusion reactors for power on Earth. Two issues there. We have to, mine it from the moon, and we also have to have a fusion reactor that works, which nobody has yet.
Right.
And then the third category of space resources is the ones that don't weigh anything, which are photons. And that would be collecting power in space and transmitting it to Earth via microwaves. Mm-hmm. So space solar power. So these are alternative ways of utilizing resources in space for the benefit of Earth, industrial scale operations on Earth, and alleviating some of the ecological and economic and national security pressures that we have to live with in today's world. So that's the third path, exploit. And most of it would be robotic, but you can't really do it without humans as well to kick the robots and make sure things are working right.
Sure.
And then the fourth and final path is what I call the settlement path. It's very different from the explore path because, remember I said for the explore path, the idea is to get people as far away as you can. For the settlement path, the idea is to put people in a place in space in which they can become self-sustaining. And this is where the distinction between Mars and the moon becomes really important. So if you really want to explore, the moon's probably not good enough as a motivator. But if you really want to settle, the moon is a far better place because it's only 3 days away.
Right.
And the way I like to think about it is if you want to settle Mars, you send Adam and Eve. If you want to settle the moon, you build a railroad to the moon. So that things that are of value on Earth can be exported back to Earth, and supplies and specialty equipment and rotating populations of skilled workers and so forth can come from Earth to the moon. So we are lucky, as Kraft Eric has said, that we've got a planet that's only 3 days away where we can learn to do all these things and genuinely turn Earth life into a two-planet phenomenon, which would be the ultimate goal of settlement. So the reason I use this framework of these four options is because they lead to very different futures, and they require very different technical capabilities. The enablers are different. And because all this stuff is expensive, it means that you have to choose your future carefully, because while you're investing in one, you're not investing in the others.
Right. Yeah, my question on this was going to be, these seem like almost exclusive path lines in a lot of ways, if we're sort of looking at, the potential for funding, that sort of thing. You said earlier when you were just describing the second path that it's a much different sort of philosophy and idea towards space than we currently have, and it would seem very difficult, at least, to pursue any of these paths simultaneously.
There is a roadmap, I think, that connects them in a logical way. and that's one of the things I give talks on. The half a dozen or so fundamental enabling technologies for each of these paths are a relatively non-overlapping set. An easy example to imagine is most people think about rockets to get stuff into space. And so if you're trying to send a few astronauts really far away reliably, you need one kind of rocket. But if you're trying to launch thousands of tons of stuff to build solar power satellites, you need a really different kind of rocket.
Sure.
And if you're trying to launch passengers on vacations into Earth orbit, you need yet a different kind of rocket. So it really makes a difference what you're trying to do. And I do believe that there is a most efficient roadmap sequence, which actually starts with demonstrating end-to-end space solar power feasibility, which would then attract private capital, so that you could scale it up to industrial scale operations based on commercial launch and commercial habitation, both of which are in the early stages of development now. Once you had that, you would have a very robust space operations infrastructure, essentially funded commercially, that was also a high power operating infrastructure. So you'd have commercial launch, commercial habitation, and a high power operating environment from which platform you could then do all the stuff that NASA wants to do anyway, right? You could go explore Mars, you could build up infrastructure on the moon, you could settle the moon, you could do all these other things if you were routinely operating in a high power environment closer to Earth. So I think there's a way to sequence them that doesn't take an entire century to unfold. But if we do it the way we're doing it now, where NASA wants to go to Mars and everybody else wants to go to the moon, that's not necessarily an efficient roadmap.
Gotcha. So in your mind, we should be looking toward more of a. It starts with the exploitation sort of section of the path and then evolves further from there.
To me, that's the most that path or that roadmap has the most potential for great things to happen. And the reason is really simple. Right now, the activities that we do with humans in space are essentially constrained by the NASA top line budget. Right, NASA gets $18 billion a year. You could imagine a scenario where it might get 20% more or 20% less, but there is no reasonable scenario in which NASA's budget is multiplied by 5.
We're not having a space race 2 anytime soon.
Well, there are other places, other nations that are intent on landing humans on the moon. Russia just announced plans again recently. China has plans for that. So it's a little hard to predict the repercussions of the American competitive spirit.
Yeah, by which I mean we're not having a Cold War with anyone actively.
Exactly. Yeah. And so, to first order, you just look at the budget math and you say, well, we're top line budget constrained. The way you get real growth and breakout into space is you alleviate the top line budget constraint. And the way you do that is by attracting private capital. It has to be more than just government investment. And so then you look to these 4 paths and you say, well, which of these paths has the capacity or the potential to attract private investors? So it's not exploring and it's not settling. It's either bringing the experience of spaceflight to large numbers of people and or exploiting space resources for benefit of Earth. Those are the two that they have the hooks that could, where you could imagine people with companies and foundations and sources of private capital saying, I can make a buck there, and that might be useful to invest in.
Given that the space experience market seems limited somewhat by high cost of launch and that sort of thing, naturally the exploitation seems the most attractive.
Well, perhaps it's all of it's high cost. I actually personally believe the thing that the valve on the rate of growth of passenger travel isn't the cost. There's plenty of people in the world with a lot more money than you or I will ever see. Well, I can't speak for you, but I can speak for myself. There's lots of money out there. I think the limiting thing is reliability. So, it may cost me a bunch to buy a plane ticket to, I don't know, London, but I'll do it because I can take a vacation there and I know I'm going to get to London. If I went to an airline to buy a ticket and they said, "Oh, by the way, there's a 2% chance you're not going to make it,"
You're just going to blow up as soon on
yeah, then I'm going to be more reluctant to pay for an expensive ticket. But if somebody said that I could go to space for 2 weeks and I have a 4 or 5 nines reliability chance of coming back, just like I do on an airplane, well, that might be worth spending 5 years worth of income as a once in a lifetime amazing experience.
Yeah, that makes sense.
I think people's calculus of what is a good value proposition is more governed by reliability than it is by cost.
Sure. A lot of this sounds like a very structured way that space settlement proponents traditionally discuss sort of O'Neill cylinders and that sort of thing, the general path to that being a private investment sort of model that takes off after either asteroid mining or space solar or space hotels starts to take off. At least that's what it's sounding like to me. It's definitely a lot more evolved than the usual sort of free running idea that people say, oh, well, money somehow will come from somewhere. So it's sort of nice to hear a more structured sort of view. And I really like this path terminology you're using. It definitely makes it easy and interesting to sort of visualize those routes.
For many years, our community of interest and advocacy and doing amazing things with humans in space, it has been gripped by, I think, a counterproductive fantasy, which is we're all interested in this just somehow, genetically almost. We get it, we love it, we grew up on it. And to us, it's self-evident that this is an important thing for humanity's future. But for most people, that's not a motivator.
Mm-hmm.
They might sort of like it as a notion, but when you get right down to it, the money has to come from someplace. Somebody has to pay. Mm-hmm. And there's only a limited amount that even the U.S. government or the government plus its partners around the world can do. And if you look at the history of expansion and settlement and so forth, there may be government forays, government exploration, for example, surveying like Lewis and Clark. Mm-hmm. But the thing that makes populations expand is that a place can be settled and you can make a living doing it. And so without those things, it's all just fantasy.
Mm-hmm. There was an earlier discussion on one of our episodes where I forget exactly who it was, and I'm very sorry if they're listening, but they mentioned that often the space settlement community looks to things like the gold rush for an example, and he was saying that it's a lot more accurate to think of something like the Panama Canal, in that whereas the same rules apply where, money is essentially the motivator. People want some easy, quick route to and from that section of the world, but the cause behind it is money. People wanted to pay more money or wanted to pay less money to traverse there so they could have more profit, so they could have more wealth. And while the government footed an initial bill for, the infrastructure, all of the actual exploitation and the colonization and the utilization comes from private interest.
Yeah.
Yeah.
And it also shares another characteristic with the Panama Canal, which is that space is really, really hard, and therefore it's expensive. And that's what the builders of the Panama Canal discovered. First the French and then us. It always ends up costing more and taking more time and costing more lives than people wanted to believe at the beginning. Right. So anyway, so that was all sort of background for a discussion of what we might do on the moon. The specific talk that you found that you asked me about was a thing I did in 2009, so it's 6 years old. It was a conference in Huntsville, and I called it "What Will We Do on the Moon?" And there's a couple of just little pieces of background about how this came to be that might be interesting. One is there was an activity that occurred that NASA hosted in December 2006 that I was invited to participate in, which was intended to, it was, I don't know, a couple of hundred people who were invited to Washington. And the idea was to get a whole lot of ideas out on the table about what could be done on the moon and then render that all down into some themes that could be used to underpin the Constellation program at the time. And so that was fun. We had multiple teams and put it all together. And out of that activity, there were over 800 ideas that were articulated, and then they were kind of collected into objectives, and then it all got rendered down into 6 themes. And it was a great chance to see some old friends and have some interesting discussions. But it got me thinking also about how do you communicate to people who are not specialists why this would all matter. And that's what really led to the talk. And so the purpose of thinking about what we would do on the moon was really to ferret out some principles for how to communicate in a way that would resonate with people. And so I just picked out of those 6 themes. I'm just flipping through my charts now. Out of the 6 themes, I think I picked 12 examples of things I called vignettes, ways that, or little stories that you could tell, pictures you could paint that would be not necessarily a comprehensive description of what we would do on the moon, but examples of the kinds of things that we might do that could resonate with different communities so that they would have more specifics, real hooks to kind of hang their thinking on.
It sounds like a lot like the show. How do I get invited to one of these?
So, NASA hasn't done one of these recently, but this thing about the vignettes that I'm talking about, I did that after the big NASA meeting. It just got me thinking.
Gotcha.
And so I put this talk together just to help the nerds learn how to talk to non-nerds.
I think that's the new tagline for Voices from L5. Nerds trying to talk to non-nerds.
The 6 themes were, one was conducting science to gain new knowledge, one was providing economic growth, one was enabling deeper exploration of the solar system, the 4th was enabling increasingly sophisticated lunar activities, 5th was improving the human condition, and 6th was establishing human settlements off Earth. So for each of those, I had 1 or 2, or in one case 5 examples of vignettes that that I would talk to people about, and so I can maybe use some of those as examples to talk about what I mean by this.
Sure.
And that might stimulate some questions on your part. A science objective you could do on the moon, which is to search for pieces of ancient Earth.
Huh.
And so here's the backstory. The oldest rocks we can find on Earth miss the first 1/5 of Earth's history, because Earth is a very active planet geologically, and there are a few places, one in Canada, some in Africa, where there are rocks exposed that are 3.5 billion years old. But anything older than that, it's gone. It's obliterated. It's been recycled into the mantle and re-erupted in volcanoes and so forth. And so we don't have that record.
Sure.
But the lunar environment is only gardened by micrometeorite bombardment. So it preserves more of solar system history than Earth does. And then if you realize we have meteorites on Earth that came from Mars, they've been proven to have come from Mars through isotopic analysis of entrapped gas bubbles. Okay, so if meteorites can come to Earth from Mars by impactors on Mars, then clearly there are Earth rocks on the moon.
Right.
So then you get to think about, if one of the uses of the moon is to search for these ancient Earth rocks, how would you recognize them? And you could begin to imagine a scientific campaign that uses robots and humans and searches and modeling and sample recovery and in situ analysis in laboratories on the moon and lab analysis back on in Earth labs and so forth, to gain insight into this missing piece of the history of Earth.
Astrogeology or astrolunology.
Yeah, it's Earth's history as determined from rocks we would find on the moon. And that's not something you normally hear people talking about.
No, that is fascinating. That's incredible.
I didn't think it up. This was, but to me, this was an example of the kind of thing that if we want people to be motivated by how we're spending their tax dollars, why wouldn't we be talking about things like this?
Right.
Because it's just kind of fascinating.
Yeah.
So let me give you a totally different one. This is more in the category of using activity on the moon to enable exploration deeper into space. So you can think of it like sometimes that people call it moon as a test bed. Mm-hmm. Okay, so here's one. I would call it next generation life support technology. So if you look at the life support technologies on space station, which is phenomenal, right? It's a bunch of machinery that keeps a half a dozen people alive indefinitely,
right?
Which is just kind of cool all by itself. But it's a lot of machinery and is very finicky. And so if I judge it harshly, I would say that today's state of the art in space life support is still operationally very primitive.
Right. I mean, the ISS was designed relatively a while ago at this point.
And it's hard. You know, we're learning as we go.
Oh, for sure.
But if you're going to go deeper into space, like places like the moon and Mars and so forth. So first of all, we have zero understanding of low gravity physiology. Right. We know a lot about humans in microgravity and a lot about humans in 1G, but we know nothing about humans in partial G. Okay. Second is we don't know how to close the oxygen loop. Well, we know how, but we haven't done it. Second is we do not have an operational technology for biological methods of purifying air and water, which you would have to have if you were going to have large populations like settlers. Mm-hmm. We have no significant food production. You know, you have a little like way to grow some lettuce and stuff.
Some cress.
But we're not growing tilapia. You know, we're not we're not growing goats. We're not. You know, there's no significant really food production. Not growing legumes and and then finally the toilet breaks down all the time. I'm exaggerating. It's not all the time. But the real question is, would you trust that urine recycler on a 3-year Mars mission? And the answer is no, it's not ready. So part of the problem is that the space station architecture, the module architecture, is designed for performing science experiments. It's not optimized for tinkering with the life support hardware.
Right.
All the life support hardware is this finicky stuff that's packed like a Swiss watch into these racks that are up against the walls. All the plumbing is inside, and you have to sort of expose the innards in order to fuss with it. So I suggest to engineers that they imagine what I call an inverted module architecture that puts critical equipment on a bench in the center, like a normal laboratory or workshop, where the components can be tested and adjusted and changed out, and that could be used as a laboratory for evolving life support technology hardware in a relevant environment. 1.6G on the moon, So nobody really has a concept for a thing like this. And I'm thinking, why not?
Right.
If you're going to use the moon as a test bed, well, maybe one of the things you want to test is the stuff that your life is going to depend on for a 3-year mission to Mars.
Yeah.
So that's just another example. Let me see if I can find another fun one here.
That's a pretty good idea, though. I mean, just not even just for the life support. If you expand that out, you're sort of talking about an inverse of what we like to, in the space community, sort of purport as a big defense of the NASA budget. The all of the technologies and breakthroughs that happened because of Apollo. You're sort of proposing that again, but as a thing that space itself can benefit from.
And yes, and that you would do in space.
Right, exactly.
So really the precedent of the thing that's just incredible and historic about the International Space Station is that it is a world-class laboratory in this unique environment of space. Well, let's do that on the moon, because then we'll have a world-class laboratory in a planetary environment, actually, for prototyping the stuff we're gonna need if we're serious about living on planets. So that's kind of the rationale there.
Yeah.
Here's an easy one, easy to think about. So remember, one of the objectives was to enable increasingly sophisticated lunar activities. So very straightforward one is dust control.
Right.
On the moon, as I'm sure most of your listeners know, the lunar regolith has been pounded into dust, pulverized into dust by billions of years of gardening by micrometeorite hits, and big hits and little hits. It's been gardened, and so it's this very fine dust. It's like the consistency of flour, but it's basically shards of glass. So they're extremely sharp. It's highly abrasive, and because you're in a hard vacuum, it sticks electrostatically to everything that rubs through it,
right,
including spacesuits and rover wheels and stuff like that. So you put these two things together, hard vacuum and lunar regolith, and it's a bad combination. And even the Apollo missions discovered that with only a few hours on the moon. So why not design around the mitigations that we're going to have to do for these bad effects? And one of the simple things that means is, if we're going to have routine surface operations, driving around, exploring, prospecting for resources, doing whatever, we're going to have to pave roadways and work areas. So how do you pave on the moon? Well, there's a couple of interesting techniques that have been proposed. One is that it turns out that if, at least in the mid-latitudes where Apollo went, if you scrape down or dig down just between 10 and 20 centimeters through the fluffy part of the regolith, you get to a layer of the regolith that is naturally compacted by the vibration and the thermal cycling and so forth. And so it's extremely compacted. In fact, if you disturb it, you can never recompact it as hard as the way you found it.
Wow.
So that makes me wonder if there's a technique where you could essentially use a grater to shave off the fluffy stuff and leave the compacted layer.
Mm-hmm.
And then the fluffy stuff you shaved off, you would sieve it and get the gravel out. And then you could redeposit the gravel without the dust. And that becomes your roadbed that you could drive on. And so effectively you're using the natural resource of the naturally compacted subsurface regolith. But here's the real key. Nobody knows if that idea makes any sense. And there's alternatives. You can do direct sintering with microwaves. You could maybe sinter paving blocks, these like interlocking things like my driveway is made out of, and you could pave with paving blocks. There's all these different ideas. Well, okay, so why wouldn't we imagine an investigation in situ that prototypes all these different ways? to figure out which one works best, or maybe which ones work better for some activities versus others, and for different scales of construction and so forth. So this is merely an example of a thing we would do on the moon, right? An investigation in situ to prototype various methods to control dust.
Too often I think we fall into these. Whenever we're asked why would you want to go into space, or why would you want to go to Mars, or why would you want to go to the moon, or whatever it is you're asked, a lot of space community folks respond with, either to make money, or just because we should, or just because we could. And I think that this attitude you're bringing up, where we just talk about really interesting, really cool stuff that people just might, be interested in just hearing it. I think that's really a lot better for promoting space and space travel and space activities to anyone. I mean, even you just telling me this, as a giant space nerd, I'm sitting here going, that's super cool. We need to do all of that stuff like right now. But I think your layperson hearing this is definitely going to be a lot more interested than some vague promises that, there's an asteroid out there that's worth $1 trillion and we need it. Like, I really think that this what you're talking about is the natural way that we should be promoting and talking about space settlement, or just space in general.
There's well, I agree. There's what's the word I'm looking for? Well, it's an irony. It's a sort of a contradiction. A lot of times, people who are professionals in our field are really reluctant to talk about specifics, because if they're technically savvy, they know that all the specifics are going to be different by the time anything really happens.
Sure.
And my view is that when you're talking to normal people, that, while it's true, is also irrelevant, because if I think back to when I was a little kid in the early 60s, I read all the books on space exploration that I could get at the library, and they showed concepts for how we were going to land on the moon. This was even before Project Apollo was named. Mm-hmm. And so they were all laid out, and they were described, and I found it, of course, lifetime inspiring. Mm-hmm. Well, by the time we did it in 1969, the LEM didn't look like, in fact, it was called the LM. It wasn't called the LEM the way it was back in 1962. Mm-hmm. And it looked different. And it didn't matter that the details that I was inspired by turned out to be different when the reality came.
Right.
It still did its job, which was to hook me into wanting to spend a lifetime in space activity.
Right.
So I agree with you. There's a sort of duality where most professionals are reluctant to commit to details because they see it as committing, mm-hmm. and what they're missing is that without the details, it's not evocative enough.
Right. I mean, I don't think anyone listening right now, if they're interested in space settlement, didn't at some point pick up, the High Frontier and read these incredible, proposals for how we're all going to live in space at some point. Or before that, I'm sure there was plenty of people listening at home who listened to all these incredible stories about moon bases and were inspired for life and loved space forever because of those stories. And I mean, we're not living on the moon right now, and most people's ideas of space settlement aren't 10-kilometer long tubes anymore. But we're still, I'm still doing this show. We're still talking about it. And I think that's really right. the key.
Yeah. So, all right, I'll give you another one.
One more to close the show out. Yeah.
Okay. So this is one of my favorites. I call it a kitchen science TV show. And so the issue here is how so-called normal processes work on the moon and affect routine activities. Mm-hmm. So physical processes like convection, mixing, drainage, evaporation, flame behavior, all these things operate differently in 1,6G and different atmospheric pressure conditions. So that physics affects practical things like how to cook, how to clean, how to live.
Right.
And you can't, in fact, design your way around that new physics ahead of time. So understanding how this new physics or how this new environment will affect what's the right way to do the practical things, you have to do it in situ. You have to develop it in place on the moon by living it and doing it.
Right.
And so I think the investigation of these things is like, well, it is a form of play. So, you fool around with something and you see what happens and how it behaves, and then you figure out how to make an omelet in those conditions. And so I think because it affects how humans live, it's about defining a new way for humans to live. It's inherently interesting to a broad cross-section of people. And so my suggestion is to, make it personal. What do we do every day just to do what we do? And how would we learn to do those things on the moon?
Right.
And
right.
I think investigating that could easily become a popular TV show.
I think you're totally right. Based on, the very, very popular videos you see on YouTube these days. I mean, how very popular was those ISS videos where Mr. Hadfield showed us how he clips his toenails? Like, those were incredibly popular. People loved those, bringing out washcloths and all that sort of thing. I think you're totally right. I think people would pay to watch someone learning how to cook eggs on the moon. I think that's completely correct.
Especially when it gets all messed up, right? Because
right. Which it inevitably will.
Yeah, right.
Exactly. Do you know how to cook an egg on the moon? I don't.
That's right. And so what I tell audiences is you can't have a space hotel until you can make an omelet and mix a martini. And nobody knows how to do that in space.
Right. Or even what's going to happen when you try to do it, really. I mean,
exactly.
I can guess that it's probably not going to look great, but, I can't tell you the specifics.
So I want to squeeze one more in.
Okay.
For you, which is what I call designer biology. And so here's my 1960s quiz. You weren't born then, probably, but when I was a kid, if you gave somebody this quiz, you say, which one is going to occur first? You would get all kinds of answers. So here's the four. Okay. One is transgenic and knockout mice. Second is DNA fingerprinting as admissible evidence. Third is cloned pets. And the fourth is a moon base. If you asked a kid in the 60s about those four things, most kids would have said, oh, we're going to have a moon base first.
Right.
And in fact, we have all three of the other ones, but we don't have a moon base.
Right.
So the other three are all about biology, interestingly. And so the rate of change of our knowledge and capability in the biological sciences is miraculous. And I would ask, what biological miracles, quote unquote, will be common by the year 2030? And that could include, for example, plants and animals that are optimized for lunar conditions. Things like hard radiation, low atmospheric pressure, different partial pressures, long dark periods, strong ultraviolet radiation, compact geometry, alien soil, all kinds of things. So imagine a laboratory on the moon devoted to developing a novel lunar ecology that meets our needs for settling the moon.
I mean, Matt Damon's potatoes aren't going to keep us living up there, right?
That's right. And so it's just another example of a topic nobody in the space community is talking about. Mm-hmm. They're all pretending that our world in 2030, 2040, 2050 is sort of just like our world today. Mm-hmm. But we certainly know enough to know that that is not going to be the case.
The thing I like most about a lot of these that you've brought up, I think the best part is that they're all, I don't want to say small ideas, but you get my meaning, right? They are things that we do, like you say, we do either every day or they just don't occur to people because they're sort of in the background of how do we build the rocket that'll get us there. That's the big thing that I always bring up when I talk about the genesis of this show and where it came from. Everyone wants to talk about what kind of rocket will get us to space settlement or space industrialization, or how are we going to build a space elevator. And those are questions that we can talk about, sure. But you're right. No one ever asks how are we going to make eggs or how are we going to harden corn to grow on the moon. But those are, in many ways, the more interesting questions. I mean,
I think so, because and they're the ones that resonate with the broadest cross section of
right.
normal people.
A rocket that'll take us to exploit, space will probably have a lot of chemicals in it, and the chemicals will burn real fast, and it'll be engineered in some really clever way that means that it doesn't cost all that much money. But we have a bunch of rockets. Rocket science, it's very complicated and very interesting to a great deal of people, but it's not very evocative to the average person at home. Not a lot of people at home are super interested in the evolution of rocket fuels. That's just not something that interests all that many people.
Right.
But space corn, or a show where we cook eggs or make martinis on the moon, that's the sort of thing people actually want to hear about.
Yeah, and the farm facility where we raise the 16G chickens
Exactly.
to get the eggs. Yeah. So really, kind of what all this comes back to is maybe two thoughts I could suggest. Number one is maybe through. Well, first of all, I should say to what you just said. That's why I call these vignettes. It's like a little glimpse, a very detailed glimpse of a thing that we would do on the moon. That's a reasonable thing to do. That's a necessary thing to do, and it's kind of interesting. And so I use those as examples so that people can begin to see that when we do go back to the moon, it's not boring at all.
Mm-hmm.
And I think that's really important for our communication with the people who are paying the bills. The other is, this is, and this is what I told the audience when I gave this talk, this is something you can do at home. I just wrote down, 12 of these ideas. But anybody can do this. You just think of stuff that you're familiar with, and then you put yourself in that weird environment and say, how am I going to do that? And so anybody can do this. It doesn't really require professionals to in the space business, and that I think also is a sort of democratizing way of approaching thinking about humans in space.
Maybe we should do it right now. If you make it to this point in the show and you're interested, feel free to tweet or post about what one of your own ideas, and maybe the best one we'll work out some kind of prize or something for.
Wow, sounds cool.
Yeah. I've never done a prize on this show before, and I'm not entirely convinced any of you ever make it this far. But if you do, send me a tweet or a message with your very best, and we'll see what we can do. Brent, you've been a fantastic guest. This is, this end bit where you just shared a bunch of those was absolutely fantastic, and I really want you to just to keep going and just say them all, but that's pretty much what we have time for.
Well, that's fine. We can. I have other topics. We can have other conversations in the future.
Yeah, I was about to ask if you have anything else you'd like to share, because I would absolutely love to have you on again. But before then,
yeah, I have lots of things. So what you and I can do is have some dialogue, and maybe some of those things will be of interest.
Sure. Is there anything for this show you'd like to mention? Any projects going on? Anything you might want people to check out if they're interested in what we talked about today?
Well, since the topic really was the moon, I guess I would just alert folks or remind folks to pay attention to what the rest of the world is doing. In today's world, it's not just about what the U.S. is interested in. And the rest of the spacefaring nations of the world have their sights set on the moon. It's partly because it's more feasible for them than Mars is, but it may be that some of these other kind of pragmatic considerations are resonating with them. And I would hazard a prediction that over the next couple of decades, our view of our role in space will shift once we see multinational crews operating on the moon, and Americans are not among them. that's going to maybe cause people to think that the moon is an opportunity that's easy to miss. And it shouldn't be, because there's a lot of ways we can use it and learn from it and expand civilization onto it and under it, inside it. And there's lots of science and lots of activities. And as a space architect, I have to say there's nothing more exciting than the idea of having to invent civilization from the dirt up.
There's an exciting thought. In the next couple decades, it will no longer have been just Americans that have walked on the moon.
Oh, it's absolutely gonna happen.
Yeah.
So,
Brent, you've been great. Thank you so much.
thanks, Liam. We'll talk again.
Bye now.
All right, see you.
Hey folks, thanks for listening to Voices from L5. A couple things before we go. I want to say a big thank you to John Boswell, who makes Symphony of Science. That's the music that's playing right now and the music that plays right at the beginning. Check him out at YouTube under Melody Sheep. Secondly, I want to say a huge thank you to all of our Patreons, but especially Nick LaCrome, our current $10 Patreon. Without you guys, the show wouldn't really be going anywhere. And biggest news of all, of course, is that this microphone that you're currently hearing me from is courtesy of our Patreon donators. So thank you very much again. If you guys are interested in becoming Patreon donators, check out my Patreon. That's patreon.com/voicesfroml5. We got some really fantastic goals and some really great stuff we want to do with the show in the future that we need a little bit of support to get there. Check it out. As little as $1 a month really does make a difference. If you guys want to support the show in a different way, feel free to like, share, subscribe, link this show around a little bit, tell your friends, and vote 5 wherever you might be listening to us. It really helps get the word out that way. Lastly, I do want to say if you guys have any interest or feedback or anything you just want to talk to me about, feel free to email me at voicesfroml5@gmail.com. I check it all the time, and I'm always on the lookout for new guests or show ideas. Thanks, guys.